Good day, everyone, and we're back again. My name is Mubarak Yusuf, and again, we're still on our pressure volume loop. So, in this video now, we'll be talking about how our contractility affect our pressure volume loop. And if we have shoot 3 videos already, first talking about our pressure volume loop and all the pressures and the contraction, the relaxation. The second video integrated the heart sound. The third video talking about how afterload and preload affected. And now we're talking about how our contractility affect our pressure volume loop. So basically, again, this is the pressure volume loop right here, and now I'll tell you guys how our contractility affect our pressure volume loop. So right here, you guys can see this is our first nice looking pressure volume loop, and contractility is basically the heart pumping harder than it's used to, right? So increasing contractility will mean the heart pumping harder. So in what condition can you have increasing contractility? For example, if you give someone digoxin, right? For example, those with heart failure that have increased contractility, decrease contractility. Or for example, if someone is given a catecholamines. So catecholamines, for example, your epinephrine working on your beta-1 receptor will also increase your contractility. Your norepinephrine will do the same thing. So basically, your contractility, what your contractility will do is that it will squeeze the heart harder so that there will be more blood ejected. If you guys hear what I just say, more blood ejected. So from that, it will mean that it won't affect your preload. So I will just use my black marker, but I'll use a dotted line. So this is how it will affect it. So basically, it's affected in a way that it just decreases the end systolic volume, right? So by the time it decreases your end systolic volume, you guys remember from our equation last time we said stroke volume is the difference between our end diastolic volume and our end systolic volume. So a decrease in your end systolic volume will mean that there will be increase in your stroke volume. So our contractility, I'll just write it here, our contractility will increase our stroke volume due to decrease in our end systolic volume, right? So, and because now there's increase in stroke volume and there is no change in our end diastolic volume, what we will have now is that there will be increase in ejection fraction. And I hope this makes sense. Just think about it. If there's increase in stroke volume and there's no change in our end diastolic volume, obviously there should be increase in ejection fraction, right? So for example, if you want to have increase in ejection fraction, so those that go and exercise also, if you exercise also, you can enter sympathetic mode and you will have a release of catecholamines, and when you have release of catecholamines, there will be increase in ejection fraction. So basically this is for contractility, and I promised from the last video that I will integrate aortic regurgitation into this. So basically in aortic regurgitation, what do we have? There is a failure of the valve, the aortic valve, to close when it's supposed to close. So there's returning of blood back to the left ventricle after systole, that is during diastole, right? So the graph will now look something like this. Basically, the graph will look something like this. I drew this to this side. It's still attached to the same graph, so it will look something like this. And now we won't have a nice isovolumetric relaxation phase. So we have something like this. And what do I mean like this? You can look at this graph and you may think this graph is funny, but let me walk through this, right? The beginning, what happened in this time is that because now there is no closure of the valve here, right? What will happen is that there's blood going back to the ventricle after every contraction. So there will be more preload, right? So as time goes on, the graph keeps shifting all the way to the time that look, there will be increase in your stroke volume due to increase in your end diastolic volume, right? There will be increase in your end systolic volume, and there will also be increase in your end diastolic volume because look, there's more blood coming back from the aorta, and again, there's more blood there's an equal amount of blood coming from your atrium, and so the graph of your aortic regurgitation will look something like this. And in your aortic regurgitation, there's wide pulse pressure. That's one giveaway. I'm giving you guys one giveaway in the question. When you see a wide pulse pressure, just go for aortic regurgitation. And this is it for our pressure volume loop. Keep your comments. I'm waiting for your comments in the drop box. Thank you very much, and I hope this helped. I hope this will help you smash pressure volume loop question. Thank you very much.